The Lion and the Curve. In the grand theater of 17th century Europe, a challenge was thrown like a gauntlet. Johann Bernoulli, a mathematician whose ambition was as sharp as his mind, posed a deceptively simple question to his peers. What is the curve of quickest descent? He dared the greatest minds to find the path a bead would take, under gravity's pull, to travel between 2 points in the shortest possible time. The problem, which he named the Brachistochrone, was a test of intellect and a bid for glory. The challenge rippled across the continent, finding its way to the brilliant Marquis de l'Hôpital in Paris and the polymath Gottfried Wilhelm Leibniz in Hanover. These men, giants of the new calculus, recognized the profound depth hidden within the simple puzzle. They set to work, their minds racing to unravel the geometry of speed and time, filling pages with elegant, flowing equations. Across the English Channel, the problem arrived on the desk of Isaac Newton. It was late in the day, and he had just returned from a long day's work at the Royal Mint. To Newton, for whom the laws of the universe were an open book, this European challenge was a mere curiosity. He picked up his quill, the candlelight flickering across his focused face, and began to work. Before the sun rose the next morning, Newton had solved it. The problem that had occupied the continent's best for weeks had yielded to his intellect in a matter of hours. He sent his solution back across the channel, unsigned. He had no need to attach his name. The work itself was his signature. The solution was not just an answer, but a revelation. When Johann Bernoulli received the anonymous proof, he stared at it in stunned silence. The logic was flawless, the insight profound. There was only one mind in the world capable of such brilliance. Tanquam ex unge leonem, he muttered to himself, with a mix of awe and envy. I know the lion by his claw. But there was a deeper, more personal rivalry at play. Before issuing the public challenge, Johann had secretly wrestled with the problem himself and arrived at an incorrect solution. Fueled by a lifelong competition, he had then presented the problem to his older brother, Jacob, a mathematician of equal, if not greater, rigor. Jacob, ever the more methodical thinker, approached the problem with patient determination. He meticulously worked through the calculus, avoiding the pitfalls that had trapped his younger brother. After days of intense effort, he found the true answer. The curve of quickest descent was a cycloid, the path traced by a point on a rolling wheel. Seeing the elegance and correctness of his brother's work, Johann was consumed by jealousy. In an act of profound intellectual dishonesty, he took Jacob's proof, copied it in his own hand, and prepared to present it to the world as his own discovery, hoping to steal the glory that rightfully belonged to his brother. However, mathematical truth cannot be so easily disguised. When the various solutions were published, the community of scholars recognized the superior logic and depth of Jacob's original work. The deception was uncovered, and while Johann had posed the question, it was Jacob, Newton, and the others who were celebrated for truly answering it. The Brachistochrone problem became a legend, a story of fierce intellect, human frailty, and the uncompromising nature of truth. The 5 men who solved it had not only answered a difficult question, but had also helped forge a powerful new tool for understanding the universe, the calculus of variations. The elegant arc of the Cycloid remains a testament to a moment when rivalry and genius collided, pushing the boundaries of human knowledge forever forward.